All right, hey everybody, and welcome. So today we're going to continue exploring the world of matter and what makes everything unique. Last unit we talked about uh, particles, states of matter, and the periodic table. And now we're going to be diving into the properties of matter specifically today. All right, so today's learning objectives, what we're going to be covering a lot. So first, we're going to start off by defining what properties are, and then we'll learn the crucial difference between physical and chemical properties, and then we'll investigate many examples of each from color, texture, all the way to the chemical properties such as combustibility and reactivity. So if we go through the objectives really quick, I covered some of those really partially, but I want to make sure I touch exactly what we're going to be going over. So first, we're going to define and differentiate between physical and chemical properties, distinguish between qualitative and quantitative observations, be able to identify and describe at least 10 different physical properties of matter, identify and describe key chemical properties of matter. This is going to cover the standard from the state, S8P1, obtain, evaluate, and communicate information about the structure and the properties of matter, and then the element C, plan and carry out investigations to compare and contrast chemical and physical properties of matter. So I think we can start working on this. Let's move forward. All right, so our agenda for the going forward is that we'll touch first about what properties of matters are, compare the two, a deep dive into physical properties, a deep dive into chemical properties, and then we'll conclude with a summary at the end. All right, so what are properties of matter? So let's take a moment and look at all of these words. You got taste, you got color, you got density, luster, malleability. What do all these have in common? Well, first, they're all words we use to describe things. So in science, these descriptions are called properties. They are unique characteristics. They are the unique characteristics that help us identify and classify every single substance that we try to uh, define. So when we compare physical and chemical properties, the most important way we classify properties is by splitting them up. So a physical property is going to be a characteristic you can observe or measure without changing the substance's chemical identity. All right, cannot change the chemical identity. Think about the color of a blue ball. Observing its color doesn't change it into something new. All right. So a chemical property, on the other hand, describes how a substance reacts with other substances, which change its chemical identity. For example, knowing that wood can burn uh, is a combustibility. It's a chemical property because after burning, it's no longer wood. It turns into ash and also smoke. All right. So, oops, sorry. I wanted to get those all out there really quick. So, we like to ask, which properties can we detect specifically with our senses? So for taste, we can taste. For touch, we can detect the properties of texture and hardness. With sight, it's color. Is it clear? Kind of texture. You could see some rigidity in texture sometimes. And with luster, you can see if it's shiny or not. And smell, you can definitely smell the difference with your nose. All right, going forward, qualitative versus quantitative properties. We can break down the properties even further. So a qualitative property describes the characteristics that can be observed but not measured with numbers. All right. Um, you can describe it, but you don't assign a number to it. A quantitative property, on the other hand, is one that you can be measured and expressed with numbers, things like mass, volume, density, temperature. All right. critical question really quick. So, which example can be both? The answer there is similar to that is like viscosity. So why would that be the case? Well, you can describe it qualitatively by saying honey is thick, or you can measure it quantitatively in a lab and get a specific numerical value. Another great example there is height. All right, you can look across the room and say, man, that guy is tall. Or if you came close to him, you could actually measure how tall he was. Like you can visibly see that one could be a qualitative property and one could be a quantitative property. Moving on. All right, so let's recall. A physical property is a property that can be observed or measured without changing the chemical identity of the substance. All right, and so let's start with some basic properties. All right, the first one, as we recall from last unit, is the state of matter. All right, this determines if a substance is solid, liquid, or gas. And we see this with water. So water in a lake is going to be in the liquid state. All right, and water in an ice cube tray is going to be in the solid state, and the water in steam, when it boils off, will be in the gas state. Next one, taste. Taste describes how a substance affects our taste receptors, or our taste buds. Okay, sugar tastes sweet, lemons taste sour, and nothing in a chemistry lab should ever taste it. Even common food items, all right, could be contaminated in a lab setting. All right, next one, odor. So the odor describes how a substance affects our olfactory or smell receptors, okay? Old gym socks smell really bad. Roses, on the other hand, smell good. And never smell anything in a chemistry lab unless instructed to do so. And in smelling a substance, the wafting or hand waving method should be used to sniff it, to bring the vapor safely to you. All right, next one is going to be color. So color is how a substance reflects different wavelengths into your light sensing receptors in your eyes. Okay. So a fire truck is red, but the sky on a sunny day is going to be blue. The leaves on the trees in the summer are green, and the color of the sun is yellow or gold or very bright yet white. The color of an orange, I bet you can guess it, is orange. All right, luster. Luster describes how shiny or dull it is. So a piece of paper is dull because it doesn't reflect light very well. But the chrome on a car is shiny because it reflects a lot of light. Another dull thing would be an eraser, and another shiny thing would be a spoon, a stainless steel spoon. Next property we talk about is clarity. That just means clarity describes how much light can pass through. Glass is transparent, meaning that it lets all the light pass through. Maple syrup is translucent because some light passes through, but mud is going to be opaque because it lets no light pass through. Again, that word is opaque, O-P-A-Q-U-E. Next physical property we're going to talk about is texture. Texture describes how the surface of a substance feels. A bowl can feel smooth, but the surface of the cement sidewalk feels rough, and the cat fur feels soft. And an eraser can feel rough or tacky. Next, hardness. So hardness describes how difficult it is to scratch a surface substance's surface. So on the Mohs scale, a diamond is the hardest substance with a value of 10. And then an emerald is also very hard at the value of 7.5. Next property we're going to talk about is solubility. We briefly talked about this in the first unit when we talked about salt and water and salt dissolving in water. So solubility describes how easily a substance dissolves when mixed with another substance. So vinegar is soluble in water. All right, salt is also soluble in water, but oil and sand are not soluble or insoluble in water. All right, next one, viscosity. So this is a new one probably for most people. All right, viscosity describes how easily a substance can pour or how thick it is. All right, so water is less viscous than oil, and that is why it pours out so easily compared to oil. Ketchup is more viscous than oil, though. That's why it pours, and it's harder to pour out than oil. I'm sure everybody's seen where ketchup gets stuck inside the bottle. Malleability. So malleability is going to be the ability to hammer or bend metal into a thin sheet. Okay. All right. So aluminum is going to be very malleable, as we know with the aluminum cans, which is why we make aluminum foil with it. Glass and wood are not malleable, while copper is very malleable as well. Next one, ductility. So similar to malleability, this one is going to be kind of like hammering, but instead it's actually making something into a wire without breaking. So many metals like copper and gold are very ductile. That's why we make our electrical cords through copper and our jewelry with gold. And then sometimes, though, substances like water or cement are not going to be ductile because, one, water is very thin and light, and when you try to hammer it, it just splashes. And cement, on the other hand, would just be brittle and crack. Next one is density. So density describes how mass is contained in a given volume. All right. Rubber is less dense than water, so it floats. A penny is more dense, so it sinks. Interestingly, though, solid water or ice is less dense than liquid water, which is why ice floats. And I briefly discussed this earlier in Unit 1, and this is because water has a special ability with hydrogen bonding. So when it bonds during its state change, it causes an expansion of its bonds, which cause extra volume inside of those particles and molecules together. All right, electrical conductivity. So electrical conductivity is the measurement of the substance's ability to conduct an electrical current. All right, so copper is a good electrical current, and which is why we use it in wiring. Plastic, on the other hand, is not a good electrical current, and it's used to insulate those wires. All right, so that's why we use plastic or rubber around to insulate those wires, because it does not conduct heat or electricity very well. All right, next couple things are going to be our phase change points. So these are specific temperatures where a substance changes state. All right, the melting point is the temperature at which it will change from solid to liquid. And the boiling point is the temperature at which it turns from liquid to a gas. For water, though, the melting point is 0 degrees Celsius and the boiling point is 100 degrees Celsius. For gold, these points are much higher, as you can see. Physical properties. So crystal formation. So crystal form describes the geometric shapes a substance makes in its solid state. Under a microscope, sugar crystals are oblong, but salt crystals form a near-perfect cube, as you can see in the picture. Next physical property, and I hate that I'm just kind of going through these really quickly, but trying to make the video a little shorter. So magnetism, it describes a substance is attracted to a magnetic field. So steel is attracted to a magnet and is considered magnetic. Glass, on the other hand, is not attracted, and therefore it is not magnetic. All right, let's recall some more stuff. So going back earlier, we talked about what a chemical property is. Now that we're done with physical properties, there was a lot of them. So now let's switch gears. All right, so a chemical property describes how a substance reacts with other substances and how it changes its chemical identity as a result. Okay, let's move forward. The first chemical property is going to be combustibility. So combustibility is going to describe whether a substance can catch on fire in the presence of oxygen and heat. All right. Glass is not combustible, where dry wood is more combustible than wet wood. And then fossil fuels like gasoline are highly combustible. Hot take. This combustibility is going to take higher temperatures to ignite normally compared to flammability, which we'll talk about in a second. Because these two different properties are going to sound similar, but they're not the same, and we'll talk about that. So flammability. So flammability is closely related, and it describes how easily a substance will catch on fire at normal temperatures. Again, that's the point difference between combustibility and flammability. It's about how a substance can be sorry, go back. How a substance can be combustible but not very flammable. It requires, so combustibility requires high heat to ignite. Flammability is just normal temperature. Next chemical property we're going to talk about is oxidation. Oxidation describes a substance's tendency to lose electrons during a chemical reaction. The most common example here that we see every day is going to be rust. Sorry, didn't mean to skip that, as you see in the picture. And then also as you've seen in bananas and whatnot, you've seen them oxidize before, where they turn from yellow to black, or if you see apples bruise when you bite into them and let them sit out in the air. All right, just got a last few of these to go. Toxicity is the next one. So toxicity is the ability of a substance to cause harmful effects on living organisms. Bleach, for example, is toxic if ingested. So harmful effects on living organisms. Toxicity. Next one is sensitivity to light. All right, so sensitivity to light describes how a substance reacts when exposed to light, and particularly ultraviolet or UV light. This is why certain medicines come in dark colored bottles to protect them from reacting with light. So that's why in the picture right there I show you guys some bottles. I don't know if you've ever seen your certain liquids that come in a bottle. They'll be in a dark like brown bottle, and that therefore they cannot be affected as much by sunlight or other lights inside your house, because it would break them down faster. Last one here is going to be the reactivity with water. All right, so sodium or the alkali metals are going to be very reactive inside of water. And that's because, remember, they only have one free valence electron, which they cannot hold as well as if they had more. So reactivity with water describes whether a substance reacts with water. So some elements like sodium, for example, are extremely reactive with water, and they react so violently that they have to be stored under mineral oil to keep them away from even the water vapor in the air. Okay, let's talk about the key takeaways here at the very end. So that brings us to the end, and we learned all properties can be classified as either physical, where the substance doesn't change, or chemical, where it reacts to become something new. And understanding these properties is the foundation for almost everything we do here. Um, in the chemistry side of physical science, I appreciate everyone for watching. So again, physical properties are going to be again the ones that we can observe without changing the substance, and chemical properties are the ones can be described how a substance reacts to form a new substance. Hence, the combustibility, flammability, reactivity, toxicity. Yeah. So I appreciate everybody watching. Have a good one.